Hello and welcome to this video on solving the walls coloring problem. Problem statement is, there is a row of n walls that need to be colored with pink, black, or yellow. Each color has a cost associated with it. We need to find the minimum cost to color all the walls such that no two adjacent walls have the same color. To solve this problem, we will use dynamic programming. We will create a 2D array, called DP with dimensions n rows and 3 columns. Each row represents a wall, and each column represents a color, 0 for pink, 1 for black, and 2 for yellow. DP0 of 0, DP0 of 1, and DP0 of 2 are then initialized with the cost of painting the first wall with pink, black, and yellow, respectively. This initialization is necessary to start the dynamic programming approach, where we will use previously calculated values in the DP table to calculate the minimum cost of painting the next wall with each of the 3 colors. Then we use the for loop, which starts at index 1 and iterates through the rest of the walls, indices 1 to n-1. For each wall, we calculate the minimum cost of painting it with each color, given the minimum cost of painting the previous wall with the other 2 colors. To calculate DPI of 0, we add the cost of painting the current wall with pink, that is colors I of 0, to the minimum cost of painting the previous wall with either black or yellow, which is the minimum of DPI-1 of 1 and DPI-1 of 2. We do the same for the other 2 colors DPI of 1 and DPI of 2, and repeat this process until we reach the last wall. Finally, we return the minimum cost of painting the last wall, which is the minimum value of the 3 entries in DPN-1. This value represents the minimum cost of painting all the walls such that no 2 adjacent walls have the same color. And that's it. With this code, we are able to efficiently find the minimum cost to color all the walls such that no 2 adjacent walls have the same color. This is a slightly optimized version of the previous code, in which we will use a rolling array to reduce space complexity. Instead of using a 2D vector with n rows, we use a 2D vector with only 2 rows, each with 3 columns to store the minimum cost of painting the current and previous walls. In the for loop, DPI modulus 2 of 0, DPI modulus 2 of 1, and DPI modulus 2 of 2 represent the minimum cost of painting the current wall with pink, black, and yellow, respectively, given the minimum cost of painting the previous wall with the other 2 colors. As we have observed in the previous code, we only use 2 columns at a time to calculate the answer. So, now to calculate the minimum cost of painting the current wall, we use the minimum cost of painting the previous wall with the other 2 colors, which is stored in DPI-1 modulus 2 of 1 and DPI-1 modulus 2 of 2. By using modulus 2 on the I index, we can use the rolling array to save memory and update the DP values only for the current and previous walls. Finally, we return the minimum cost of painting the last wall, which is the minimum value of the 3 entries in DPN-1 modulus 2. And that's it. With this code, we are able to optimize the space. There is one more video on this rolling technique on the array, which you can see from the right corner I button. I hope this tutorial was helpful, and if you have any questions, feel free to ask in the comments. Thank you for watching.